So our last RP specific topic that we're going to dig into is something called Anycast RP. And what Anycast RP is designed to be able to do, at least in what we kind of would potentially use it for in the lab, is to allow us to have two active RPs servicing the same range of groups at the same time. If you think about it, we haven't really done that specific use case yet. We've been able to do multiple active RPs, but always for different groups. And we've been able to have multiple RPs service the same groups, but not at the same time. One's active and the other's waiting in the wings. So this is going to allow us to do two RPs for the same groups at the same time. And it leverages a technology or protocol called MSDP for this all to work. So if we look at a little bit of a design, if we saw this in something like the lab, what we would see is we would have two different switches that are going to be active on the RP side. And the way that this is going to be able to work is that they are going to advertise the same IP address at the same time. And so when we tell everyone who the RP is, the RP for every group is 1.2.3.4 or whatever it is, both of these switches would be advertising the IP address 1.2.3.4. This is the Anycast part of it. And why this works is that they're loopbacks and they're just advertising these routes into the routing protocol. And so what will happen is just whoever the closest switch is from a routing perspective is who that particular switch talks to for its RP functions. And so it sort of load balances a little bit, and it also coordinates with each other. MSDP allows for this coordination because switch 1 might have some RP information going on over here, switch 2 has other RP information going on over here, and they use MSDP to share this information. So both switches know what's going on across the entire organization, which multicast senders are out there, what groups are active on different VLANs, things like that. And so if one ever goes away and all of a sudden the switches that were talking to switch 1 are now talking to switch 2. Switch 2 already knows what's happening, and everything just kind of keeps on going as needed. And the convergence is fast. It's as fast as your routing protocols converge, whereas some of the other technologies where we had maybe active backup type things, it can take a little bit of extra time for the detection to sort ourselves out. So we're going to start off talking the classic design of this. And so we'll start off with that shared IP. We're going to configure a loopback interface on switch 1 and switch 2 that is exactly the same IP and mask. We need this to be identical from a routing perspective. And so we'll just say that our loopback 0 will be the shared IP address, and we'll make it be 5.5.5.5/32, a classic loopback subnet mask there. And then we would advertise this into our routing protocol. And that way, people can talk to 5.5.5.5. Now, in a classic design, we would also create a second loopback interface. And this loopback is specifically there for peering, the MSDP peering between the two switches. And so these will be unique IPs so that they can talk back and forth between each other. And so we'll just say that switch 1 uses 1.1.1.1/32, and switch 2 uses 2.2.2.2/32. And then we'll peer between these loopbacks with MSDP. The MSDP setup, you don't really honestly need to know hardly anything about MSDP other than just how to get a peering set up. So there's really only 2 commands that we'll put in there, one for the peering and one extra one that's always recommended in this type of a setup. So how we're going to peer. When we set up the peer, if I'm going to configure switch 1, I would say basically peer to switch 2's unique IP address, so 2.2.2.2. And then I'm going to say I'm going to specify what interface am I sourcing the peering communications to, and that's from my local loopback, 1.1.1.1. And then switch 2 is just going to be the flip of that. So switch 2 is going to peer to 1.1.1.1 from 2.2.2.2.2. And what you see here, these are basically inverses of each other. Switch 1's destination is switch 2's source, and switch 2's destination is switch 1's source. And if we have it set up like this, the peering should come up just fine. So don't forget to specify where we're peering from. We have to specify both the to and then as well as the from. And as long as they're inverses of each other, we should see this peering come up. And then MSDP can do its job and coordinate all that awesome stuff that it does. And then once this is finally up and configured like this, the last step is we still need to tell everyone who the RP is. This doesn't advertise out who the RP is. This just sets us up for active-active RP communications. Most of the time in an auto RP scenario, we would use a static mapping because the RP IP address will never change. It's the same on both. So a static mapping is actually a perfect solution for something like this, although you can use auto RP or BSR or any method that you want to tell everyone who the RP is. My guess is you would do a static mapping. So let's show you the configuration. It's a technology not a lot of people have even maybe heard of, especially us wireless guys. Don't let that throw you too bad. It's very simple what we might have to do with it. So first step is really staging. Let's go ahead and get those loopbacks in there and make sure that they're working. So right now, switch 1 and switch 2 will be my two switches running Anycast RP. I have multicast routing enabled, PIM sparse mode everywhere. I don't have any other things configured at this point. So let's create those loopbacks. So loopback 0 will be our shared interface, or shared RP, so IP address 5.5.5.5 with the /32 subnet mask. And then we'll just configure the exact same thing on cat2. Int loop 0, int loop 0. Okay, then we'll create the second loopback, which is the unique one. So int loop, oops, I forgot what to do one more thing on that. I need to turn on PIM. Since this is going to be the RP interface, and the fact that it's just a layer 3 interface, I need PIM on it. So let me get PIM on there. IP PIM sparse mode. IP PIM sparse mode. Okay, now let's get that second loopback. Int loop 1, I am on switch 1, so this will be IP address 1111. No shot, IP PIM, again, sparse mode. Doesn't technically need it on this one, but I'm just going to put it there because why not? Int loop 1. Sorry, IP address 2222, 255.255.255.255. No shot, IP PIM sparse mode. Okay, so I've got my two loopbacks. Now, anytime you add a loopback or any interface, usually it's a loopback, make sure that it is being added into your routing protocol. Without that, no one can talk to these two different IPs. So let's take a look at our routing protocol. And what are we even using? I see a D there. So we're using EIGRP. And actually see switch 1's IP, so that's a good sign, but show run section EIGRP. Okay, so under EIGRP, we see that I have that blanket network statement that's going to match every single interface ever. So I'm good there. Probably have the same thing here, show run section EIGRP. Always make sure that these interfaces get added into your routing protocol, otherwise they won't work. And if you want, you could do a quick little ping test. I'm on cat 1, so ping 2222 source 1111. Whoops, let's spell source right. And that works. That's from 1111 to 2222. The ping works. We can talk. We're safe to go ahead and move on. Now that I've got staged up, I've got my two loopbacks configured. They're in the routing protocols. I can ping back and forth between them. Now we just need to get that MSDP peering going. And it's a pretty simple command, IP MSDP peer. Okay, where are we peering to? I'm on switch 1, so I'm peering to switch 2's loopback of 2.2.2.2. And then say connect source of my loopback 1 interface. I have to actually put the interface name, which is 1.1.1.1 is the IP address. Over here, just do the inverse of that. IP MSDP peer 1111 connect source my loopback 1, which is 2222. They should start talking. The peering should come up. One thing you'll see is once you actually configure the peer command, this extra MSDP command comes in automatically, IP MSDP cache SA state. I'm not going to pretend I know exactly what that does, but leave it in there. There's really 3 commands that are very common and recommended in this Anycast RP setup. 2 of them are right here, and so we'll add the last one in, IP MSDP originator ID. And this just needs to be unique. I think this is similar to a router ID in our routing protocols, and we just want to make sure that we have a unique originator ID. Since we have shared IP addresses, we just don't want that shared IP address to be it. So just specify the loopback 1 interface, which is unique. And it looks like my peering is up. We'll do this on both sides here. And that's honestly should be the only 3 MSDP commands you ever see, and you only need to type 2 of them in because one of them is automatic. Show run include MSDP. So these 3 MSDP commands, you type in the peering command, make sure you specify that you're sourcing it from your loopback address. This comes along for the ride, leave it there, and then we specify an originator ID. Again, I don't know if this is 100% required, but in every single config guide I see, it's there, so may as well just make it a habit of putting that in there. And if you want to verify the peering, show IP MSDP peer. And here's my peer, 2222. We see a state of up. That's what we want to get to, state of up. That means that they're successfully communicating with each other. And now that I have MSDP working, they're able to share RP information. The last step is just tell everyone that the RP address is 5.5.5.5. So let's go ahead and do that. IP, PIM, RP address, 5.5.5.5. Do this on every single switch. Show IP, PIM, RP map. There we go. We just have a static mapping saying that for every group, 5555 is our RP address, and hopefully should be able to test. Ping 239.1111. Hey, there we go. I think I also have 238.111 still active. And there you have it. So that's the Anycasts with Auto RP. Again, let's just rehash the steps. We're going to create, in a classic design, 2 loopbacks. One is that shared loopback, same IP address, same subnet mask on both sides. Then we're going to have a unique loopback on both, so different IPs with their own networks. Make sure that they can talk to each other. Set up the so add them into your routing protocol. Set up your MSD peering. Make sure that they're just inverses of each other. So switch 1 is peering to switch 2 source, and switch 2 is peering to switch 1 source. And once that peering comes up, add in that MSDP originator ID command, tell everyone who the RP is, and then you should be up and running. Now, a couple of other things with Anycast RP. If we look back at our interfaces here, show IP in brief, exclude unassigned, what you'll note is now we have a loopback interface with the exact same IP address on 2 switches. Show IP in brief, exclude unassigned. What does this mean to us? Well, we are now at risk of running into a duplicate router ID scenario in our unicast routing protocols. Because the way that they pull, they grab their router ID by default is they're going to look at one of the IPs on the switch and pick one of them. And what does it prefer? Well, it prefers loopbacks over non-loopbacks. Uh-oh. And it prefers the highest IP'd interface over a lower IP'd interface. So look at this, loopback, and it has the highest IP address of all loopbacks. Loopback with the highest IP address of all loopbacks. So what does that mean? Well, right now we're still okay. Show IP EIGRP topology. Because EIGRP already picked its RP address its router ID address prior to us configuring MSDP. But if we ever reboot these switches, they're going to pick that 5555 as a router ID, and now you're going to have duplicate router IDs. So anytime you configure an Anycast RP scenario, you potentially have this risk. And so what I would highly recommend is if there's any doubt in your mind as to which IP address it will use as the router ID dynamically, configure it yourself. And in this case, absolutely it would. So I would definitely want to make sure I'd go into IP router EIGRP and say router ID, EIGRP router ID. And just something unique, 1111. And that way, because these switches can reboot after you leave the lab. So even if you left the lab and everything was still okay, you don't know. Power events happen. I don't think that the proctor is going to purposely reboot it, but why even put yourself in that risk? So always be thinking about a duplicate router ID possibility anytime you do an Anycast RP setup. Now, you don't technically have to use a second loopback for the peering. You always have to have that first loopback that's the same on both sides, because that's the only way to advertise really the same IP into the network without issue, especially if the two devices are right next to each other. But that second loopback is really just for the peering. And then we have one other way of peering, assuming we're directly connected with each other, which we are in our topology. So rather than create these separate loopbacks, what I could do is I could just pick a connected interface and peer between that. And right now, I believe we're peering from a unicast perspective across VLAN 10. And so I could just peer using the VLAN 10 IPs and just naturally, switch 1 would source it from its VLAN 10 interface when it talks to switch 2's VLAN 10 interface and vice versa. And so we should be able to do that. If you didn't want to create that second loopback, or you weren't allowed to for some reason, I will say the second loopback is by far the most standard design, because it allows these devices to be spread out very far across your network. It's just only when you're directly connected do you really have this other option of choosing a non-loopback interface there. Or you could actually, even if you are spread out, you could choose an outgoing interface, but the beauty of the loopback is that it's not tied to any physical interface. So if this link goes down, but I have another link to get to the switch through another spot, the loopback still works. Whereas if I'm choosing outgoing interfaces, if that outgoing interface goes down, even if I have another path through the network to get to the other switch, MSDP breaks. So loopback, by far the best solution. But if you want to, we could switch up that peering command. Show run include MSDP. I could take that away and say IP MSDP peer 10.10.10. Oops, sorry. 10.10.3. And on switch 2. Take away its previous config. IP MSDP peer, just something on the same VLAN 10.10.10. And that should also work. Show IP MSDP peer summary. Oh. IP MSDP summary. So we're listening right now. We're not quite up yet, but it can take 30 seconds, a minute or so for it to come up. Show IP MSDP summary. All right, while we're waiting. And again, it can take a minute or so for this to come up, but it should come up again as long as they can talk to each other. 10.10.10.3. Again, there we go. Came up. So you don't have to do that second loopback, but I would say unless told not to, I would make the second loopback your default. So that's Anycast RP. Yes, it's not explicitly written out in the blueprint, but I wouldn't be talking about it if I didn't think that there was a decent chance of you seeing it. So just give it some practice. Once you do it a few different times, you'll see that it's really not too big of a deal. Just go step by step, get those loopbacks in there, into the routing protocols, peer it up, tell everyone who the RP address is, and you should be good to go.